Lingappa from PES University, Bengaluru, and Ratnakar Malar, Jhanavi R, and Pallavi LS from TCS, Bengaluru. The work was successfully completed with the help and guidance. Hello everyone. Today we are going to present the paper on design of a real-time tracking and telemetry parsing system for S-band satellites. The work was carried out by myself KG Dikshita, Chaitanya Patange, M. Harshita and Chaitra Nijalingappa from PES University Bengaluru and Ratnakar Malar, Jhanavi R and Pallavi LS from TCS Bengaluru. The work was successfully completed with the help and guidance of Manikandan J. Sir and Nagendra Rao Sir from PES University Bengaluru, Amagand Biradar Sir, Ullas Pradhan Sir and Sai Prasad Sir from TCS Bengaluru. Decoding satellite signals refers to the process of interpreting the data transmitted by a satellite and converting it into human readable format. Demodulating and decoding satellite signals involves a complex set of techniques and algorithms to extract data from the signals transmitted by the satellites. The data collected by these satellites can be used for various applications such as weather forecasting, military surveillance, and scientific research. The Sindhunetra satellite, which is also known as SINE, was designed at PES University along with RCI DRDO and was launched by ISRO. The aim is to design a telemetry parsing system for S-band satellites, which involves demodulation and decoding of the satellite signals, and also to design a graphical user interface for showing the telemetry data in real time. The proposed work is carried out using a ground station with S-band antenna commissioned at PES University and with the help of software-defined radio module. This is the block diagram for the proposed model. The proposed model contains the Sindhunetra satellite tracked from the antenna with the help of antenna control unit and G-Predict software. The azimuth and elevation values are calculated using the TLE, which is a two-line satellite orbital information. The azimuth and elevation values are sent to the antenna with the help of antenna control unit, and the antenna is pointed towards the satellite. The signals are received and converted to human readable format using HackRF SDR module, which are then viewed in GQRX software. The signals are demodulated and decoded using the GNU radio. The Python script is used for the telemetry format decoding and viewing the data in the GUI in real time. The implementation of the proposed model. A 3.5 meter parabolic S-band antenna dish is a part of the ground station setup for receiving signals from the S-band satellites. The antenna is mounted on a rotating platform which is capable of automatically tracking the satellite using an antenna control unit designed by PES University. The GIF here represents an S-band antenna in PES University which is tracking Sindhunetra satellite. The radio frequency signal received from the S-band antenna is converted into a computer-readable format using the HackRF1 SDR module. This conversion process enables the subsequent processing and analysis of the received signal. This is the HackRF1 module used for this proposed model.
I'm Harshita. I will be explaining the different signal processing techniques used to demodulate and decode Sindhunetra satellite signals. The system involves signal processing stages such as RF spectrum analysis, frequency translation, automatic gain control, Costas loop processing, polyphase clock synchronization, Viterbi decoding, and telemetry data display on the GUI. At the Osmocom source block, the raw signals from the SDR is transmitted. These signals are passed to the throttle block where it limits the rate of flow of the signals. It is further passed to the remote DC spike block where it removes the unwanted center frequency leak. These signals are passed to the frequency escalating FAR filter where the decimation of the signals takes place, and at the RMS AGC block, it maintains a constant frequency in the signal. At the Costas loop block, the signals are locked to the center, which helps to eliminate the Doppler effect, and also the Costas loop helps to demodulate the signals. These demodulated signals are then passed to the polyphase clock sync where clock synchronization takes place. The demodulated data is decoded using the CCSDS NASA GSFC Viterbi decoder block, and the decoded data is then passed to a TCP sync block where we give the IP address and the port number, which is then connected to a Python program where the further decoding of telemetry parameters takes place. These are the spectrums obtained after passing through each of the blocks in the signal flow graph. The first figure shows the spectrum of the raw signal received from the satellite. The second spectrum shows the removal of the unwanted center frequency leak. The third spectrum shows the decimated signal. The spectrum obtained after when it is passed to the COSTAS loop is shown here in red. It logs the signal to the center, that is at 0 kHz, and the blue indicates the input. It helps to eliminate the Doppler effect, which helps in demodulating the signals. The constellation diagram after demodulation is shown below the spectrum.
I am Chaitanya and I'll be explaining the Python part. The decoded data from the GNU radio is sent to the Python code over a TCP connection. This data is then converted to binary and the frame sync word is searched in the binary data to locate the frames. On finding the frames are then split in the telemetry format to extract the telemetry parameters which are shown on the Python GUI. This is the GUI for the Sindhunetra satellite coded in Python. The satellite is tracked using the gPredicts software and this is the spectrum of the satellite obtained. The demodulation and decoding is done in the GNU radio and the decoding to obtain the telemetry parameters is done in Python. The GUI shows the number of frames which is the live count of the number of frames obtained so far. The telemetry parameters include the mainframe ID, the subframe ID, the temperature of the IMU, the onboard time of the satellite. Also, the latitude, longitude, and altitude of the satellite, along with the live azimuth and elevation values needed to track the satellite, are shown. The ground trace of the satellite, along with the azimuth elevation polar plot, is also shown on the GUI. Subframe plots and OBT time plots are also plotted in real time and shown on the Python GUI.
I am Chaitra. I will be discussing the results of proposed model. The path of the science satellite over PS University for different dates are shown in this figure. It represents the polar plot for azimuth and elevation angles. The plot shows the live position of the satellite along with its path. These are the RF spectrum from GQRX of different satellites which are tracked by the antenna in the PS University. So these are some S-band satellites like USA 176, SIGN, ResourceSat and OceanSat. This is the performance evaluation table of the proposed model. The comparison of the single co-stars, two co-stars and hybrid of both the models are shown in the table. The figure of merit is the ratio of the obtained frames and to the expected frames. So the table contains of past date of the satellite, expected frames and obtained frames and a figure of merit of single co-stars, two co-stars and hybrid model. The hybrid model gives a maximum FOM of 0.996 and an average FOM of 0.924. So we conclude that the design and evaluation of the real-time tracking and telemetry parsing system of an S-band satellite called Sindhunetra using the PS ground station and HackRF SDR module is proposed. Three models are designed with single co-stars, two co-stars and hybrid model and their performance are compared. The proposed hybrid model yielded a maximum figure of merit of 0.996 with an average figure of merit of 0.924. The future scope of the proposed work is to extend the same to other satellites whose onboard modulation and encoding schemes are available. These are the research papers referred during the implementation of the proposed models. We sincerely thank AGERS 2023 for giving an opportunity for presenting our research work. Thank you.
Okay, thank you for the nice video from the Deshi- Deshita, I forgot. Okay, is there any question for her for the research? If no, I would like to ask and maybe some ingestion for the knowledge about your research. So I was wondering, what will be the disadvantage for the your your system because you design the graphic unit interface in your system using the Python from the um, uh, scratch to until maybe until the is a real time. What will be your uh, disadvantage for this your research? Thank you.
We can monitor the health of the satellite.
Hello, can you repeat again?
We can monitor the health of the satellite. So we are decoding the telemetry data of the satellite, which is the health condition of the satellite, which is revolving around the Earth's orbit. So by decoding this data, because there are many universities which is launching satellites, so we will be with our proposed model, we can decode the telemetry data of such satellites and monitor the health status of the satellite and accordingly give the tele command to the satellite so that the satellite is performing in the proper range.
Okay, any problem when transmitting your data at that time, Mr. Miss Dexita?
Uh, Sir, we are actually only receiving the data from the satellite. The transmission part is done through the institutions which have launched the satellite. We don't have the uh, operating. We can't telecommand the satellite, but we can receive the signals and decode them. So presently, a lot of decode demodulation is happening through hardwares. So this is a software system where we are getting a figure of merit of 0.94.
Okay, thank you
Something.
for your answer. Is there any question?
Yes,
Okay, Dr. Arifin Nugroho, please.
thank you. Thank you, Dr. Iqbal. Uh, I just wondering first, please explain about the figure of merit that you mentioned around 0.98.
Yeah.
And um, secondly, um, secondly, did you uh, did you take into account another sources of impairment signal or noises coming from maybe another sources, another satellites, which are using the same frequency, something like that. Since you are using S-band, I believe, in which I believe there are so many systems using the same, and it could add on some level of quote unquote noise, which may affect your performance. Okay, thank you.
So the figure of merit is actually the frames obtained to the actual frames which is supposed to be present for a particular duration of time. So that figure, so according to the calculations, we have got 0.94 as the figure of merit. So 94% of the frames are being received. for that particular duration of time. And second question is, for the answer for the second question is, we are just concentrating on that down frequency, and when we have the other signals present in that frequency, we eliminate that. We are just locking it to the frequency. We are just locking that, the signal part. So the other part's noise is eliminated. So we are doing that. We have eliminated that part by downsampling the signal. And when we are downsampling the signal, we are also cutting down the part where the noise is present. So we're only concentrating on the signal, and then we are locking it to the center and then demodulating it.
Okay. Okay, thank you.
Okay, is there any question from the audience? If no, it's still 5 minutes, so maybe we can move on to the next presenter. So we give a big applause from Dikshita for her great research. Thank you very much.
Thank you, sir.
As I mentioned in the first one, we have Ahmad Shukri for the first presenter. Is it here? Nope. Okay. We move on to the second presenter. So, Miss Karam Salih and her colleague Najla Badi Al-Dabah. Is it right?
Yes, sir.
Okay. You will present or present with the video?
I will present.
Okay. The time is yours. You have 20 minutes maximum. Okay.
Okay.
Yeah, you can start.
Ladies and gentlemen, thank you for joining me today. It's my privilege to present our research, Custody Chain Guardian, Blockchain of Custody Digital Evidence Preservation System, by the authors Karam Mohammed Mehdi Saleh, Najla Badi from Nineveh University and University of Mosul. As we delve further into our research, it's important to lay the groundwork by understanding the problem and solution of our paper. The problem first start with the problem of traditional methods of digital evidence preservation. It's a manual documentation and physical transfer in chain of custody process susceptible to human errors, loss, and intentional manipulation, concerns about evidence reliability and honesty. So the challenge is potential loss, damage, or manipulation of evidence. In addition, compromise integrity and admissibility in court, also vulnerability to human errors and intentional tampering. So this problem is the proposed custody chain guardian framework, which is a multi-layered methodology designed to address the limitation of traditional evidence preservation method. The framework utilizes blockchain technology, leveraging the characteristics of openness, decentralization, and immutable ledger. The CCG framework aims to ensure the integrity, authenticity, and traceability of digital evidence throughout its life cycle. It addressed the shortcoming of traditional method by enhancing security, reliability, and audibility in forensic investigation. Digital forensic investigation is a systematic process for identifying, preserving, analyzing, and presenting digital evidence for law enforcement, legal proceeding, and forensic analysis. While chain of custody is a crucial procedure in evidence handling for investigations, it involves documenting the chronological events related to evidence, ensuring its authenticity from discovery to court presentation, ensure evidence integrity and admissibility. Overview of a CCG framework. This system is structured around 4-layered architecture, each layer serving a crucial role in safeguarding the evidence. The first layer is a front-end layer, the second one is cloud layer, the third one database layer, then the final one is blockchain layer. Now let's delve into custody chain guardian framework. As we said before, it starts with the front-end layer, which is user-friendly interface for evidence submission and management by different types of users. Enable easy upload and validation of digital evidence details. The second layer is a cloud layer, which is robust storage and backup repository implemented on Google Cloud platform, prevents a single point failure problem and also ensure uninterrupted data availability. The third layer is database layer, which is primary repository for storing original digital evidence. Also assign unique identifiers, ID, using cryptographic hash, and implement strict access control for authorized entities. The fourth layer is a blockchain layer, which is introduce immutability and transparency of chain of custody. Also, it uses a permissioned and private blockchain for access control and smart contract for evidence transaction, like creation, transfer, removal, and retrieval. Smart contract functions create evidence, transfer evidence, remove evidence, and finally get evidence. First, in create evidence, users can generate unique digital evidence through the system, ensuring a traceable creation process. In transfer evidence, the smart contract facilitates the secure and transparent transfer of digital evidence between authorized users. In remove evidence, creators can request the removal of evidence, demonstrating a commitment to privacy and data management. In get evidence, users can efficiently retrieve digital evidence with the system automatically assigning unique IDs, enhancing traceability throughout the evidence lifecycle. There's two operational scenarios in our system. The first one is normal operation under normal conditions. All system functions, create, transfer, remove, get evidence, operate seamlessly. Users can interact with the platform without any disruption, ensuring the system's reliability in everyday use. While the second scenario is abnormal activity with the tampering detected, the system proactively identifies and alerts user about any tampering incidents, ensuring the integrity of digital evidence. Real-time notification empower users to respond immediately, maintaining trust and authenticity within the system. So here's the experiment results of two scenarios. The first one is normal operation and the second one is abnormal activity with tampering detected. Here's a comparison between protocols which they use in blockchain technology. We made a comparison in final cost between a number of protocols like Istanbul, Berlin, London, and others. Also, we made a comparison in gas price and in gas used. Finally, we found London protocol is the best one, so we used it in our system. Here we conducted a comparison between our system and other digital evidence preservation systems that have utilized blockchain technologies. CCG distinguishes itself by key features like preservation technology and single failure backup. In single failure backup, our system enhances system reliability by preventing single point of failure. Also in preservation technology, it's incorporate advanced preservation and cloud technology, setting it apart from other systems. The conclusion about custody chain guardian framework, it's a comprehensive solution for digital evidence preservation, ensure integrity, authenticity, and traceability throughout the evidence lifecycle. It's a four-layer architecture, enhanced security and trustworthiness. Finally, it creates a secure platform for digital evidence management. Future effort for the CCG framework should focus on staying abreast of emerging technologies, ensuring scalability, providing user training, maintaining regulatory compliance, and conducting continuous security audits. Thank you.
Okay, thank you very much for the nice presentation from Karam Muhammad Salim. So, is there any question from the audience to ask her research? If no, I would like to have insight for your research topics. So I have two questions maybe. First one is how does the custody chain guardian ensure the integrity and security of custody data stored on the blockchain? And then the second, what measures are in place to prevent tampering or unauthorized access to custody records? Okay, thank you.
Thank you. Sorry. This framework is work as a decentralized system. So there is a decentralized network of nodes. So these nodes may present the court, the law enforcement, the police officer, the lawyer, anyone. So each node has a copy of the digital evidence. Actually, this process, evidence preservation, is a part of digital forensic process, which is the third step in digital forensic. The first step is evidence collection. The second step is evidence analysis. The third step is evidence preservation. So this system is present the third step, which is the evidence preservation system. So every part in the law enforcement, in digital investigator, and the police officer have a copy of this digital evidence. So when the blockchain is connect all these nodes together. So here we make an authenticity and transparency, just like the idea of cryptocurrency, because blockchain is used also there. So when we have any tampering for the digital evidence in any part of this network, all other nodes will know directly about this.
Thank you for your great answer. So there is a question from the chat box. What metric do you use to measure the integrity of your system? From Dr. Arifin Nugroho.
Okay. The metric actually is the blockchain technology itself. It's we use the Ganache development tools to simulate the blockchain environment. So when we success in blockchain technology, so this is the metric of integrity, because everybody know that blockchain technology is it's immutable and cannot be hacked or change.
Okay, is there any question from the audience again? Okay, maybe is enough. Thank you for your nice presentation and your video presentation.
Thank
Uh,
you, sir.
please give a big applause for her about the research. So thank you very
Thank
much.
you. Thank you.
Okay, next we move on to the next presenter. I'm calling the first presenter again, Ahmad Shukri, or the representative. Okay, next we move on to Cici Lestari, or the co-author Guntur Bagus Pamungkas is it here? Guntur Bagus Pamungkas, can you present? Hello, Mr. Guntur. Maybe we move next presenter, then we move to Mr. Guntur again. So the next presenter, Miss Musharofah. Are you there?
Yes. Yes, sir.
Yes, sir. Can you present, or you want to present the video presentation?
Sorry, Mister.
Sorry, what?
Uh,
Technical.
Mr. Guntur is uh entitled affordability of health service.
Oh, okay.
No.
Maybe you
Yeah.
want to present
Yeah.
now.
Yeah. Our person.
Okay, maybe Miss Lestari present first, then after that Miss Musharofah.
Cici
Please.
Lestari.
Yeah, please, Miss Cici Lestari, the time is yours.
Yeah. Please allow me to share the screen of the material, Mister.
Yes, sure. Please make a full screen. Thank you.
Okay, hello everyone. Let me introduce myself. My name is Cici Lestari. I will present the result of my paper entitled Affordability of Health Service for Cancer Patients in Mojokerto area. Okay. The first is introduction containing cancer as a health problem. Cancer is a serious health problem in Indonesia with significant effects on individual health and a high mortality rate. Because of increased cancer cases, the increase in the number of cancer cases is caused by several factors, such as unhealthy lifestyle, poor diet, exposure to harmful chemicals, genetic factor, and certain types of cancer such as breast cancer, which is high prevalence in Indonesia. Next, furthermore, the discussion about the method used, among others, correlation analysis method in research use a correlation analysis method by utilizing data on the spread of cancer in the Mojokerto area. and data on the location of health facilities. Required data. The data required in this study includes the number of cancer patients in each sub-district in the Mojokerto region in 2022. This data show the number of cancer patients in each sub-district in Mojokerto, displaying the number of cancer patients in each sub-district such as Sumobito, Kesamben, Gondang. Most sub-districts have a low or zero number of cancer patients, but there are some sub-districts such as Soko, Bangsal, Trawas, and Ngoro that have a more significant number of cancer patients. It can be seen from the table listed. Next is result and discussion. On the map, it On the map, it can be seen that there is only one health facility that can be reached by cancer sufferers in the Mojokerto area, namely RSUD Dr. Wadin Sudirosodo, which is in the middle of the Mojokerto city and Regency area based on what was obtained. There are three sub-districts in the Mojokerto area where it takes 20 minutes to reach the Mojokerto Regional General Hospital. However, in the southern region, the travel time to the hospital can reach more than 30 minutes. This information and analysis can be visualized through the map attached below. Then the last one is conclusion. Based on data regarding sub-district point experiences is experiencing the spread of cancer in the Mojokerto area, it was found that the longest travel time to reach the hospital was 33 minutes, while the average travel time to the hospital was 34 minutes. There is only one health facility on the Mojokerto area that provides treatment for cancer sufferers, so it can be concluded that the affordability of the health facility still does not cover all areas in Mojokerto. Trawas, Gempol, Gondang, Prigen, and Pacet district, for example, take an hour or more to reach the hospital. Therefore, it is hoped that there will reach regarded the affordability of health service in Mojokerto Regency. So what will be better, and the government needs to prioritize health facilities as a top priority. Thank you for your attention. This is Mark. Thank you.
Okay. Thank you very much for your short presentation from you. Is there any question from the audience to Mr. Mrs. Chichi? Sorry. Okay. Okay. Please, Mr. Oni,
Yes.
right?
Yes.
Okay.
Since Ms. Chichi, you employ network analysis to assess the accessibility of health facility in Mojokerto. How does network analysis compare to other methods in terms of accuracy and efficiency in mapping health service distribution and accessibility? That number one. And then number two, and how can your study result can inform the strategic placement or give information to the Mojokerto population or to Mojokerto city official? Inform the strategic placement of new health based on your study. That's two questions. Thank you.
Please answer the question, Ms. Chichi.
Sorry, sir. Can you repeat the question?
Yeah, first questions, what is how you compare your network analysis to other method? Why you use the network analysis, and the second, how you can inform based on your result to that new facility should be located in such place based on your result to inform the official, the government official, or to locate how. That's number two.
Sorry for no, I can ask words, sir. Sorry. Maybe I can repeat the first, and then it can be a reference to my paper.
Okay.
Okay. I'm sorry, sir.
So the answer based on your paper, Miss Chichi. Hello, Miss Chichi.
Yeah,
Maybe difficulties network.
yeah, but basically, but Bucici result that the cancer facility in the Mojokerto should be increased in quantity. That was your final result. I think that's based on the result of network analysis. My question is how you compare with other analysis, and number two, how you can inform. So the strategic location, because here you're talking only about number. Is it quality of the?
If the network is not good, maybe Mr. Guntur can help for answering the question. Okay, maybe the network is still a problem for both. Okay, is there any question for Miss Chichi again? If from the audience? Okay, no. If no, okay, we will give a big applause for Miss Cici for her research, for the great present today. So thank you very much for your presentation. We will move on to the next presenter, Miss Musharrafah. Are you there?
Yes, okay, sir.
Okay.
I start to share my screen.
Yes, sure. You have 20 minutes to present. Okay, thank you.
Hello, everyone. I'm Musharrafah. I will present our paper with the title Systematic Geometric Correction Method of Stereo Image Data Purposes for the Next Indonesian Satellite. We are from Research Center of Remote Sensing, BRIN. This is the outline of the presentation. Indonesia is one of the countries that has a high level of vulnerability, risk level, and frequency of natural disaster in the world. Therefore, technology is required to deal with the disaster, both as a prevention effort, handling during disaster, and after disaster. By using this technology, it is expected to minimize the risk and impact of the disaster that occur. Satellite remote sensing technology is one of the technology that can be used to predict potential disaster, identify and map pre-disaster condition, and also post-disaster damage. The important part of remote sensing in the field of natural disaster management includes mitigation, preparedness, crisis response, recovery, and reconstruction. As a country with a high risk level of potential disasters, Indonesia has been developing its own Earth observation satellites from Lepen A1 to the Lepen A4 that soon will be launched. And for the next generation of Indonesian satellite, we hope it is expected to be able to produce image data that can be used for stereophotogrammetry. Stereo optical image data can be used to make a digital surface model, which is a digital model of 3D representation of the Earth's surface. Information about the shape of the Earth's surface obtained from the SM data can be used for modeling various disasters, such as monitoring and controlling floods, land subsidence, landslide, etc. The accuracy of the resulting DSM is directly related to the accuracy of the image matching algorithm used. Besides the image matching algorithm, another thing that affects the accuracy is the orientation of the image, which depends on the sensor model used for registration. The sensor model describes the geometric relationship between the spatial object and the spatial image, or vice versa. In general, there are two sensor models, which is physical sensor model and the generalized sensor model. The physical sensor model is used to represent the imaging process physically, using the position and orientation information of the sensor, that model with appropriate linearity condition and equation. In contrast, the general sensor model does not use the position and orientation information of the sensor. In the general sensor model, the transformation between the image and object space is represented as some general function, which is polynomial function or rational function. And the rational function model is one of the widely used general sensor model due to its high accuracy compared to the physical sensor model. So this paper studies and proposes a general sensor model to be applied to the stereo optical image data from the landscape imager of the next generation of Indonesian satellite. This is the development of Indonesian satellite. The first satellite is A1 or 8-sat. It was developed in Berlin in cooperation with TU Berlin, and it was launched in 2007. The mission of satellite is environmental monitoring. The payload is CCD video camera, and the specification can be seen in the table 1. The second generation is 8A2. It was developed in Bogor, and it was launched in 2015. Its mission was maritime monitoring. It carried optical payload and also automatic identification system on board. It also carried amateur radio payloads and automatic packet reporting system that can use for emergency communication during disaster. The detail of the optical payloads of the 8A2 can be seen in the table 2. And the third one is 8A3. It was developed in Bogor. It's in cooperation with IPB, and it was launched in 2016. Its mission was mainly Earth observation. It carried optical payload and magnetometer. It also carried eyes, and its optical payload consists of multispectral line imager and digital space camera. The specification can be seen in the table. And the data of LAPAN-A3 has been used to monitor pedophile, spill detection, and measurement of Earth magnetic fields. This is the next generation, it's LAPAN-A4. It was developed in Bogor and designed to be in the same synchronous orbit. It will be launched soon. It's still under development. It has mission similar to LAPAN-A3 for Earth observation and maritime monitoring. The specification of LAPAN-A4 can be seen in the table 4. It also will carry the sensor from former BPPT. It is a long-wave infrared sensor. So, remote sensing satellite with pass-beam sensor are increasingly used today. For example, for Landsat, Spot, EOS, and at observation 1, the linear array of CCD is arranged in a position perpendicular to the direction of flight of the satellite. The technique of photographing the target is done line by line. Different areas of the target surface are imaged line by line in the long-range direction of the satellite. The line by line results are stored sequentially to form a two-dimensional image. The pass-beam imaging geometry can be seen in the figure. And this is the detail of image acquisition with pass-beam sensor. For accurate mapping from space, the sensor system must view the same ground area from two different positions. The ratio of the baseline between exposure to the height must be between 0.6 and 1.0 to achieve acceptable elevation accuracy. To occur stereoscopic coverage by linear array sensor, it should use side lapping flight orbit by organizing two sensors in a convergent manner or by scanning simultaneously at different angles. But the resulting image is not always ideal due to irregularities caused by illumination, linearity of satellite motion, curvature, and topography of the Earth's surface. This irregularity distort the image, which will affect the quality of the image, both geometrically and radiometrically. Therefore, geometric and radiometric correction are required to reduce the influence of distortion and improve the image quality. This is the explanation of the general sensor model of pass-beam camera. So, to obtain the high level of image quality, we need to do a high level of geometric correction. Sensor model can perform systematic geometric correction to the image orientation. Sensor model are a crucial element in expressing the functional relationship between image space and object space. The choice of sensor model depends primarily on the performance and accuracy required, the imaging system, and the control information available. This table describes the comparison between the physical sensor model and the generalized sensor model. For physical sensor model, it is usually mathematically complex and still facing the challenging task of recovering the exterior orientation of the sensor using GCP to estimate the unknown parameter. It also requires complex software with longer computational time, and the software must be adapted for each different and incoming image sensor. It is not applicable for every sensor. For the generalized sensor model, the recurving of exterior orientation of the sensor and the estimation of the unknown parameters can be handled by generalized sensor model. Without modeling the physical imaging process, the generalized sensor model transforms the image into the object space with some general function, such polynomial or rational function. It does need to be adapted for its different sensor, and it is applicable for every sensor. There are 4 generalized sensor models used in photogrammetry and remote sensing application. There are polynomial model, grid interpolation model, ratio of polynomial model, and the universal time image geometry model. One of the generalized sensor model that is widely used is rational function model. Typically, RFM is the ratio of polynomial. RFM does not depend on sensor and platform. One of the considerable interests of RFM is the flexibility in the coordinate system. Object coordinates in any system, such as geocentric, geographic, or any map projection coordinate system can be accommodated by RFM. The RFM duplicate the projective equation, such as the direct linear transformation, that are represented as the ratio of two first-order polynomial. The ratio of first-order term represents the distortion caused by optical projection. The second one represents the distortion caused by earth curvature, atmospheric refraction, lens exposure, etc. And the third one is distortion from higher order component like camera vibration, etc. Stereo image can be occurred by CCD, linear array sensor with two different configurations. You can see in the figure. It can be cross track and a long track. In the across-track configuration, a mirror that rotates from one side of the sensor to the other across the flight direction is combined with the CCD line and the optical system. The long track is constant and close to zero, and the coastal angle is usually up to 30 degrees. According to this configuration, the stereo images are collected from different objects with the overlapping area across the flight direction. In case of sensor with a long track stereo capability, the stereo images of the same area are taken along the flight direction with a time delay in the order of seconds. Images acquired based successively for the start or flight path of our airborne not only have overlap in a long track direction, but also may have a small overlap in the cross track direction. In an RFM, image pixel coordinates are expressed as the ratio of polynomial of ground coordinates. For the ground to image transformation, the different ratio of polynomial have the following form of equation, where U and V are the normalized row and column indices, and of pixel in image space, and X, Y, and Z are the normal coordinate value of object point in ground space. And P is a three-dimensional polynomial and is the polynomial order, and A are polynomial coefficient, that called rational function coefficient. RFC can be solved by two solutions, which are terrain-independent scenario and terrain-dependent scenario. The terrain-independent scenario use non-physical sensor model, while terrain-dependent scenario do not use physical sensor model. The polynomial coefficients are addressed to rational polynomial coefficient as well. The term of the RPC model is usually assigned to a definite condition of the RFM that is in forward form and has third-order polynomial and is generally figured by the terrain-dependent scenario. To compute the normalized coordinate, the following equations are used, and U, V, and U denote offset and scale value for the two image coordinates respectively. And similarly, XO, YO, ZO, and XSY, SDS denote offset and scale value for the object coordinate. In the RFM, the maximum power of each object coordinate and the total power of all object coordinates are limited to 3. For example, based on the literature we read, according to the Space Magic Economist definition of coefficient, each polynomial has the following form, which leads to totally 80 RPC per Economist image. Actually, in the Economist RPC, the two polynomials is used in the denominator are identical, where the first coefficient of the denominator is 1.0. To avoid the case where the denominator becomes close to 0, it's practically have of 59 parameters. Usually, RFM can also be computed based on rigorous sensor model with the given parameter of the rigorous model, and by projecting evenly distributed image point into the object space, multiple layer 3D object point can be computed and used as a virtual control point. Such control points are created based on the full extent of the image and the range of elevation variation in the object space. The entire range of elevation variation is sliced into several layers. Then the RPC are calculated by a least square adjustment with this virtual control point. For tackling possible oscillation of least square solution, it suggests using a Tikhonov regularization. Statistical analysis of estimated parameter could be a better approach with the goal to exclude those which are not safely determinable. If the RFM are computed from the a priori orientation parameter, we need to improve the cubosation accuracy of the RFM with a certain number of GCP. As proposed by Rudy and Dia, the method to block adjust the high error satellite image described by RPC camera model. The RPC block adjustment method is related to geometric property of the physical camera model, and it is numerically more stable than traditional adjustment of exterior orientation parameter. This adjustment method is generally applicable to any photogrammetric camera with a narrow field of view, calibrated stable interior orientation, and accurate exterior orientation data. This condition makes the method suitable for most of the high-resolution satellite imagery data. This is the proposed RPC block adjustment is defined in image space. It uses the normalized RPC model, UNV, to express the object space to image space relationship, and the adjustable function, delta U and delta V, which are added to the rational function to capture the discrepancy between the nominal and the measured image space coordinate for each point I on image E. The mathematical model is defined as follows, where U and V is defined as this equation. A polynomial model defined in the domain of image coordinate is used to represent the adjustable function, which can be expressed as the following equation, where the A0, A1, A2, B0, B1, B2 are the affine parameter for each image. The block adjustment model expressed in the equation above is justified for any photogrammetric camera with a very narrow field of view. Using this adjustment model, we expect that parameter is used to absorb all along track errors, causing offset in the line direction, while parameter absorb cross track error, causing offset in the image symbol direction. Due to the fact that usually the direction is equivalent to time, parameter, and absent the shear effect caused by zero drift during the image. In addition, the parameter are used to absorb part of the radial ephemeris error and interior orientation error. The validity and performance will deteriorate with increasing area or field of view size and rotation of the satellite during imaging, and with increasing of height range and lack in good GCP distribution. These models are geometrically and numerically more stable than the complex physical number. So the conclusion, based on the study analysis, to have a precise systematic geometric correction for the next satellite program, it is suggested to inject the RFM method into the processing system. This method applies to various sensors and has been used by several satellite image processing systems. However, it's become our curiosity to experiment with the RFM method using dummy satellite images that have similar specification to our next satellite imagery. As for further research, we will generate TM data and auto image from the dummy satellite imagery and systematically correct the image using RFM and compare it with another method. This is the end of our presentation. Thank you.
Okay, thank you very much for your nice presentation, Ms. Rofa. Is there any question from the audience about her research?
Yes.
Okay,
Yes,
Dr.
Rekla. Yes. Thank you very much. Appreciate the presenter has been showing the effort based upon literature. There are so many literatures has been analyzed. I'm just wondering if there are so many methods which finally he led, or the team led to a choice of RFM, something like that. Do you think you are going to do some kind of simulations in this case in order to justify your, what you call it, your choice, your final choice, or the final algorithm for realizing what you call generalized sensor, right? So in this case, I'm just wondering if you are going to do some kind of simulations. And secondly, what sort of parameters are you going to judge as a metric for distinguishing one method to the other? Certainly, you are going to do a lot of simulation, I believe, and then coming up for certain parameters which are appropriate for judging that the method being chosen or the candidate of algorithm would be performing a lot better than the other system. So I'm just wondering what sort of metric you are going to use for choosing such. Thank you.
Should I answer directly?
Yes.
Yes.
Sorry, I forgot for the first question is that there are many questions. Can you repeat it?
Questions. First question is whether you are going to do some kind of verifications of the method using some kind of, I don't know, maybe some MATLAB simulation or things like that, and in order to to judge that your system is performing what you are expecting. And secondly,
yes, I can answer one by one because for the first question, I think it's yes. This is still a preliminary result of our research. It's still a study literature, and based on the study literature, that RFM is, I think, one of the best for the stereo image. Actually, in our research center of remote sensing, we also do the game generation, and we use the commercial software, and RFM is actually already in that commercial software, and so many research in game generation is used that RFM, and for the next plan, we will develop the software, I think, with the Python or C. Actually, last year we already developed a systematic geometric correction software also, but the physical sensor model, based on physical sensor model, and we already experiment with the aerial image acquired by UAV, and maybe next year we will continue to develop the systematic geometric correction software based on RFM. And we will use the data maybe spot that almost similar with the next 8F4. That's from the question number 1.
Okay. Fair enough. And now about my second question, how do you compare from from different algorithms that you may wish to have the best?
The parameter we will see is the accuracy. So we compare the result of the image that corrected by RFM with the real coordinate in the ground accuracy, and also the visual of the image.
What about the the complexity of the algorithm?
Uh, uh, we cannot answer it yet because we no, this time we only know the theory. We haven't conducted. We have not conducted any experiments. So maybe after we do the experiment, we will answer their question for comparing the algorithm between RFM and another method. Is it enough?
Okay, thank you. Okay, Pak. Thank you, Pak.
Yeah, time is over, I think.
Okay, the time is up. Time, maybe you can directly ask question to her. So, Musharrafa for her great research. Thank you very much. Okay, next presenter will be Mr. Oni Bibintoro. Yes, you there? Okay.
Yes, I'm ready.
Okay, you have 20 minutes to present. Please, the time is yours.
Okay, thank you. Thank you, dear moderator, dear presenter, and audience. Bismillahirrahmanirrahim. Good morning, good afternoon, and good evening. My name is Oni Bintoro. I will share my presentation. My PowerPoint. Can you do this? No. Can you? What do I do? Can you see my presentation?
It's still processing, sir.
Oh.
Okay, now it's showing.
Okay, good. I'm going to make full rotation. Okay. My topic, urban evolution prediction, cellular automata-based land cover change analysis in Surabaya, 215-221. And the authors, Clarissa Novanti Ayu, Teguh Haryanto, Bangun Mulyo Sukoyo, with their affiliation, Geomatics Engineering Department, Institute of Technology Surabaya, Indonesia, Pak Umboro Lasminto, Oni Bibin Bintoro from Civil Engineering Department, 10 November Institute of Technology, ITS. And my affiliation also with the Research Center for Geospatial National Research and Innovation Agency, BRIN, Jakarta. So this study investigates the dynamic transformation of Surabaya urban environment from 2015 to 2021 by employing satellite imagery and cellular automata simulation to predict alteration in land cover. This study provides essential perspective for the field of urban planning and environmental management, emphasizing significant urban expansion and its consequence, thus providing direction for sustainable development approach in Surabaya. The study centered on critical components such as road network, river, and the central business district through the analysis of land cover change and the prediction of forthcoming shift Utilizing the CA model, cellular automata, the random forest algorithm was employed to analyze data obtained from Sentinel-2 satellite imagery on the Google Earth Engine cloud platform. The background, the land cover definition, the physical appearance of land such as rice field, forest, settlement, plantation, water body, and vacant land. The land cover change in land cover can be said to be changes that occur in appearance of objects. A description of the area, Surabaya municipality population for 2021 were 2.88 million people. Surabaya municipality has population growth rate in 0.28% in 2021. Meanwhile, the sex ratio of Surabaya, it's 98. Basically saying figure can be interpreted that 100 female population, there is 98 male population. And the urban sprawl, because of the economic growth of 7 to 17%. So East Java, it's higher than the average of national. In the background, this is the Surabaya Central Business District, the most expansive one. We use the Sentinel-2A satellite imagery. Sentinel-2 can be used for land monitoring purposes, basic data for land use that can be used for various environmental monitoring and planning application. We also employ Google Earth Engine. It's a cloud computing that provides satellite image data as well as satellite image data processing facility. The algorithm was chosen, random forest algorithm, because based on the previous research, the random forest algorithm has an accuracy of value of more than 0.8. Cellular automata is a method that has proven to be a superior method in predicting land spatially, supporting parameter road network, river network, and the central business district. This is showing some news in the local media that how Surabaya increased their infrastructure. And as a result, there is also growth in the population. And at the same time, it increased the number of central business districts. So what is the problem statement? The problem statement, how was land cover in Surabaya City in 2015, 2018, and 2021 with random forest algorithm using GEE? What is the prediction of land cover change in Surabaya City in 2030 using cellular automata simulation? Plus, problem statement, how to analyze the result of the adjustment of the prediction of land change in Surabaya City in 2030 with the Surabaya City RDTR, a detailed map in 2014 to 2034. Research location, the research location that we use, the Surabaya City, the boundary with the border in north with the Madura Street, and in the east with the Madura Street, and in the south with the Sidoarjo Regency, and the west with the Gresik Regency. Data that we use, number one, 2015 and 2018 Sentinel-2 level 1C imagery, in 2021 Sentinel-2 level 2A imagery available on Google Earth Engine. Number two, land cover map of Surabaya City in 2015, 2018, and 2021 issued by the Public Housing and Settlement Area and Land Office of Surabaya City, scale 1 to 2051, 25,000, sorry. Surabaya City Administration boundary data released by the Geospatial Information Agency. The river network data in Surabaya city area issued by Geospatial Information Agency. Road network data in Surabaya city are issued by Geospatial Information Agency. Data on detailed spatial plan RDTR of Surabaya city for 2014-2034 issued by Public Housing and Settlement Office of Surabaya city. Surabaya City Central Business District coordinate data from tagging result using Google Earth Pro. The equipment that we use, the Google Earth Engine, the ArcGIS, the Office 365, and the QGIS. The land cover treatment. The flowchart of land cover. The following is explanation of the flow diagram above. Atmospheric correction is carried out on level 1C image with the SciEx algorithm using Google Earth Engine. Step 2, the image is then subjected to cloud masking and subset of the research area. Step 3, the next stage is sample training by taking sample in the form of point in each line cover classes, which consists of 6 classes, namely road, building, water body, green open space, rice field, and pond by taking sample from minimum line cover data totaling 50. Step 4, carry out classification using a supervised classification method using machine learning using the random forest algorithm. Number 5, after carrying the classification, an accuracy test is carried out using a confusion metric from the classification result, where the result is the value, the accuracy value will be displayed. So land cover prediction processing, this is in Bahasa, so I will explain the English translation. Step number 1, processing driving data using Euclidean distance to produce distance map to road, distance map to river, and distance map to CBD. Step 2, processing is continued to determine change in the percentage area of each land use. Step 3, the research use an artificial neural network model and multi-layer perceptor network to create transition potential modeling. Step 4, making a land use prediction model is called cellular automata simulation, where predicted year is equal to previous year plus year range. In this research, 2015 is the starting year and 2018 is the ending year, and the year span is 3 years. So the resulting prediction year is 2018 plus 3, 2021, which with one iteration. If you want to predict several years into the future, such as 2030, the number of iteration increased to 4 times. Testing this research was carried out by comparing the result of land cover production prediction in the city of Surabaya in 2021 and the result of land cover classification in the city of Surabaya in 2021. So result of the turning point, determination of land cover class is determined based on regional regulation of number 12 of 2014 concerning Surabaya City Spatial Plan, which adjusted to the image used in the study. This is the land cover class: building, road, water body, rice field, pond, and green open space. This is the type and classification. Each class has a number training point ranking 3 to 75 point. The total number of training point used in 2015 was 314. 2018 there were 311 point. In 2021 there were 304 point. And this is the distribution. Result of turning point, that's in year 2015, the year 2018, and year of 2021. The land cover result, this is the land cover result. They have some change, and we will show the table, year 2015, year 2018, and year 2021. The comparison of the accuracy of each training point composition obtained from the classification confusion matrix, 60-40, 70-30, 80-20. Meaning, not all overall accuracy for all training composition above 0.85 are in accordance with the USGS. So this study used an 80 to 20 composition, namely 80% training point as a sample point and 20% training point as a validation point. Because this composition produces an overall accuracy above 0.85 and has a kappa accuracy value included in the category of almost perfect accuracy opportunity based on the classification of kappa coefficient value according to the Cohen. So land cover result, the land cover class in the form of building has increased in the area from 2015 2021 from this into this. Meanwhile, the line cover classes that experienced the largest decrease in area from 2015 to 2001 was the line cover classes in the form of rice field. This one is decreased to 4,841.78. The largest land cover change is the building was increased by 31.7, increased by 4,874. The addition of building class occurred. Meanwhile, the land cover that experienced the largest reduction in area was rice field by almost 40%. And the land cover that experienced the largest reduction in area in 2018 to 2021 was the rice field class with a reduction of 32.80%. Meanwhile, the land cover class in 2018-2000 what experienced an increase in area was building 22%. The land cover class that experienced the largest reduction in area was the rice field with a reduction of almost 40%. So land cover prediction result, factor supporting land cover is road, river, and CBD. And correlation between factor supporting land cover is almost 0.99 between CBD and river, between road and CBD. So the correlation between central business district and river and road is very strong because it is close to 1, which is 0.99 and 0.8350. This means that the closer the land cover is to river and CBD and roads, the faster the change will be. Land cover prediction result 2021 land cover prediction model. The land cover change consists of area change and matrix of land cover change transition for 2015 to 2018. The class that experienced the largest increase was the building class, while the land cover that has the largest area reduction is the rice field. Cover change based on the diagonal has a value. This shows that water body have a high chance of changing to other land cover classes. Correlation between supporting land cover. We calculate the kappa. The validation carried out using the resulting kappa value was 0.4, and the match between the two map was 63%. This value shows that this model has a fairly good agreement. Multicolor, we have to write for not autocol, but multicollinearity test aggregation model. The land cover prediction in 2030, the area percentage will be 61%, the road 16%. That's the land cover prediction result for 2030. The prediction result for 2030 in accordance with the Surabaya City RDTR of 46% occur in the building class in the Sawahan district area, and it didn't match by 53.8% in the pond and rice field classes in the Benoa. So the conclusion and the recommendation. Between 2015 and 2021, the urban landscape of Surabaya underwent a substantial transformation, which was predominantly marked by urban expansion, as this investigation demonstrate, to guarantee a balance between environmental conservation and development. The study emphasized the criticality of incorporating sustainable practice into urban planning. Mapping and forecasting land cover change has been significantly aided by the implementation of cellular automata simulation. Thus, this simulation provides urban policymakers with available resources. Further investigation is warranted to examine the potential application of this model in other swiftly urbaning city and to improve their precision. Using cellular automata simulation and satellite imagery, the research conducted a true examination of the dynamic urban environment of Surabaya. The funding of this study are utmost important in the field of urban planning and environmental management. Using the random forest algorithm to analyze Sentinel-2 satellite data on the Google Earth Engine platform, the research center on critical enclement including road network river and the central business district. Between 2010 and 2018, the result indicated a significant decrease of 40% in rice field accompanied by corresponding rise of around 30% in building and 20% in road. And additionally, the research implies that 40% of land utilizations will confirm the detailed spatial plan LDTR of Surabaya, where 50% will deviate from this such standard. End of my presentation. Thank you very much.
Okay, thank you very much, Mr. Oni Bibintoro, for your nice and descriptive presentation. So I am giving the audience to ask a question to Mr. Oni Bibintoro. Any question from the audience? Okay, yes, please, Dr. David Cook.
Firstly, thank you very much, Oni. That was a very, very comprehensive presentation, and I really like the research you're doing. I'm always very skeptical about some of the use of this kind of thing because cloud cover in Indonesia is such a big problem. But I was kind of excited to see some of the integration with additional data sources. So I wonder in the future, is the plan to use a little bit more, I call it data fusion, to include other sources to help to validate for a much more accurate, permanent, ongoing research project?
Yes, I agree. So in some area there are a cloud, and then also hinder the satellite capturing the image. But of course, we can use the radar satellite, the Sentinel, the SAM-band. That's number one. And number two, of course, as your recommendation, the use of the fashion model, it's I think it's more common. So like my colleague, one of my colleague here, or my actually supervisor, professor that make presentation in this morning, Pak Teguh. So we combine with the unmanned aerial vehicle. So it's not only the satellite, that they can also use with other data. And thank you, Dr. David Cook. I think that's what we going to into that direction. Thank you.
So is there any question for Mr. Oni Bibintoro?
Yes, can I?
Okay, please, Dr. Arifin Nugroho.
Thank you very much. Pak Oni, it was excellent presentation of yours. First, did you use three-dimensional analysis for the data coming from Sentinel, for example, in order to get the correct figures of the data regarding, for example, the building, and certainly the building in the metropolitan, such as Surabaya, would have needed kind of three-dimensional in order to have an accurate analysis concerning this. And secondly, what do you think about whatever result you have indicated in your analysis? To what extent that such prediction made by cellular automata methods can predict the what you call it, kind of a limit or a threshold by which a metropolitan should follow certain standard based upon a good standard of living. So,
Okay.
for example, you did, I think you know what I mean. So
Yes.
please explain. Thank you.
Yeah, thank you, Dr. Arifin. So first question on using the 3D. We are not using the 3D, the digital elevation, but we use satellite, but not the 3D. It's sometimes the data is more expensive, if difficult to hide. But this, because this is more on larger area, not at this stage. Not at this stage. That's number one on the 3D. And number two, what we have from this result, actually the results show in every city in Indonesia, by regulation, they have some detailed plan on what will be the city in 20 years time. So 2014 to 2034, that is the RDTR. But here, by using this simulation, and so in Surabaya, between 2015 to 2021, is actually the land cover change is already changed a lot. So meaning the change is a lot. At the same time, the RDTR is actually deviate what we plan and what in the reality. So what we have to do, of course, we need to replan. We need to change our plan before at the end, because 2014, 2034, before 10 years from now or 5 years from now, we have to adjust, because otherwise the environmental balance, the uh, the life of the inhabitant will be more difficult because of the growth of urban, the land cover showing into more urban area. And that's things that probably by having this, the citizen can participate on the discussion in which direction is the city should go based on this type of exercise research by using the GE and some Sentinel data. That is my our research conclusion, and also our research contribution to.
Okay, thank you, Pak Oni, and good luck.
Yeah, thank you, Pak Arifin. Thank you, Dr. David Cook. Thank you, Pak Iqbal Habibi.
Okay, thank you for your question, Dr. Arifin Broho. Is there any question for Mr. Oni Bibintoro? Okay, maybe the last question for me. So, I was confused for your methods that your title using the cellular method, automata, but your content mostly using the random forest. How do you compare this random forest, this function for which methods, or the cellular method automata, what do you use for? Because I didn't see that much on the cellular automata, mostly in the random forest. Thank you. Sorry, your mic is not on, Mr. Oni.
Okay, The random forest algorithm was employed to analyze data obtained from Sentinel-2 satellite imagery on the Google Earth Engine cloud platform. Well, the utilization of cellular automata is to implement artificial neural network to simulate land use change yielded a model that achieve an accuracy of 60%. So it's different purpose and different application, random forest and the cellular automata in this study. And so the random forest algorithm was employed to analyze data obtained from Sentinel-2 satellite imagery on the Google Earth Engine cloud platform. Well, the utilization of cellular automata to implement artificial neural network to simulate land use change yielded a model that achieve accuracy of 63% as indicated by kappa value of. So they have two different application. The random forest is for the data, the the cellular automata is for the simulation, and then we compare.
Okay, thank you for your answer, Mr. Oni Bibintoro. So is there any question on last question?
So the automata thing is kind of extrapolation, isn't it, Pak? It's going to be some kind of predictions in the future as to which the land cover would be taking the lead, something.
Yeah. Normally the prediction using statistic, but this one is using simulation, and the simulation is using what they call the cellular automata Markov chains, and based on the nearest, they make some simulation on what happened based on the previous one that they can predict what happened in the future.
Interesting. Thank you, Pak Oni.
Okay, maybe that's all. Is there any question? Last question? No. Okay, that's all. If there is no question, we give a big applause for for Oni Bibintoro for a great research and insights. Okay, I have some announcements before closing and photo session in this room. So I have an announcement. Wait a minute. Okay. So I give some information. So there is some technical in AGERS. So you have to some document. So first, author is completed with the number. Karam need remove the footer and mistake, and then Miss Chichi Lestari need a copyright registration and final manuscript to complete with, and Mosha Ofa as same as Karam remove the footer, and then last Oni Bibintoro need the figure correction because it's a low resolution. Thank you. That's all for the information. Maybe you can open the camera to take the photo session together. Please, committee, to take the photo. Okay, I'm counting to 3. So 1, 2, 3. One more time for big smile and pose. Okay. One more. 1, 2, 3. Smile. Okay. Thank you very much. We will announce the best presenter in the main room. You can get to the main room, then wait about 5 to 10 minutes for the discussion. Okay, thank you very much. Have a good day. Thank you.
Mama, let's start me. Mama, start me.